Hello, everyone. I trust you are all as well as can be. Welcome to Frontline Systems webinar on optimization using the power of Analytic Solver plus RASON. Thank you for joining us in this virtual gathering to briefly talk about and share some of the possibilities that Frontline Systems software offers to build and test your optimization models and deploy and manage your models as cloud services. I am very pleased to tell you that with us today, we have the special presence of our President and CEO, Daniel Filestra. I'm not sure if Dan's microphone is connected, but Dan, if it is connected, you're welcome to say hello. Yeah, he doesn't. Okay, Dan doesn't have a microphone. And this presentation usually takes about 45 to 60 minutes. You're welcome to type your questions in the GoToWebinar chat box. Either Dan or I will try to answer them by end of the webinar. After that, at the end, if you would like, you have the opportunity to ask questions, talk about your projects, and share your business goals and problems with us. Here is our plan for today. We start with a brief overview of Analytic Solver Desktop and Cloud. Then we model and solve a transportation optimization model together from scratch. After that, we show you how with only a few clicks, we can deploy our transportation optimization model to the Azure cloud to run it as a cloud service using Analytic Solver plus RASON. Then we move beyond analytic models in Excel or RASON and show you how you can create a web app and work with Microsoft Power BI. Today, we use Analytic Solver and RASON tools. Analytic Solver may be familiar to you, but RASON may not be. In a nutshell, RASON Decision Services is Frontline's Azure-hosted decision management suite. Is the tool you can use to deploy your models. So our goal for you today is to start with building your first optimization model in Excel using Analytic Solver, and then show you step by step how you can deploy your model for use across your organization. RASON is the deployment platform, and it is the easiest way to deploy your models as cloud services so that other people can use your models and run them over and over again. And we will discuss details on deployment and RASON as we go along. Another good news I want to share with you is that Frontline has made this even easier for you with the Create App feature in Analytic Solver. It gives you a window into RASON so you can build, test, and deploy all within Excel without any need for programming. So let's open Analytic Solver for a quick overview of the ribbon. If you install Analytic Solver desktop version, after installation, the ribbon will appear. You might know that you can easily switch your licenses from desktop to cloud version, and it allows you to check out your license from desktop and log in and use your Analytic Solver tool from the convenience of your browser and run your models. I'm going to also show you a brief overview of the ribbon in the cloud version. So let's start from top left. This is the ribbon for Analytic Solver. You can see that it has Analytic Solver and data mining. With Analytic Solver, it gives you all the tools you need for optimization, simulation, Monte Carlo simulation, risk analysis, decision trees, decision tables, and also deployment. So let's walk through these tabs. First one is Model tab. If you follow me, when I click on Model tab, it displays or hides the task pane on the right side. On the model drop-down, you have additional options that allow you to build multi-dimensional models in Excel that takes you beyond the two-dimensional world of Excel. It's really cool tool, especially if you have large models and you change them a lot. There's a very nice chapter in our user guide talking about how to define cubes, define operations such as reduction, and calculate your results using the multi-dimensional model. Next is simulation model group. Simulation model group allows you to set up Monte Carlo simulation models. You can click on distributions to access a range of predefined probability distributions, common distributions, advanced, exotic, discrete, and so on. There is also a distribution wizard that can help you choose the right distribution for your uncertain variables. This is the topic that we would cover in details during the simulation webinar next week. You can induce correlations or use the results button to calculate statistics, risk measures, range values, Six Sigma measures, and much more. Next, we have the optimization model group. These are all the tools you need to define your optimization models. First is decisions. So this is how you define your decision variables, constraints for normal constraint, chance constraints where it comes to uncertainty. Analytic solver offers you all the tools you need for stochastic optimization, robust programming. So you have chance constraints, variable type bounds. When you want to have integer variables, binary variables, then you have the objective. Define your objective. Next is parameters tab. Parameters tab provides the options to run multiple parameterized simulation and optimizations. So instead of sitting there manually changing one of your parameters and rerunning the optimization, you can actually define a parameter and rerun the models as many times as you need, or for each specific value. Solve action tab allows you to solve your optimization problems or run your simulation models. So in this group, next we have the Create app. Let's click on Create app. This is the focus of our webinar after modeling an optimization problem. This feature creates a version of Excel analytic model that will run outside Excel. This is our breakthrough bridge between what you can do in Excel to model and solve your business problem, and then what is now made available to you to create a version of your model that will run outside Excel. So with this tool, you're only a few mouse clicks away from deploying your Excel model to run as a cloud service, which nearly can be used by any application. And we will come back to this in a few minutes. So then we have the analysis group. You can get different reports for optimization, simulation, and sensitivity analysis. You can get different charts depending on if you're running multiple optimization. When you have parameterized optimization or single optimization, decision trees. You can publish your models for use and distribution on the web. You can fit distribution to historical data. And then we have the get data option. Get data allows you to bring data into Excel. You can do this different ways, and it allows you to bring in a statistical representative sample of your data from different databases, from file folder, or use our big data patches for clusters. Next is options. Options give you different options for your simulation, optimization model, and all other tools that are available, such as trees and much more. Next is licensing. So here with the license tool, you can check your license status, you can upgrade, and much more. Help. Let's click on help. So I'm just going to click on help here and see what is available. Help allows you to access our user guides. It also helps you access all the example models that are shipped with our products in different industries. For example, they show you how to define optimization model in finance, transportation. All the examples we will be showing, there's a version of them available in example models. It shows you dimensional modeling and much more. So if you're interested to learn more, feel free to click on user guides. Gives you all the available user guides. And for learning more about optimization tools, analytic solver, user guide is a very good one to start. Okay, then let's click on example models. Here you can access all the example models for optimization, for example, in different industries. Oil and gas, steel cutting, bond and portfolio management, and much more. Also, from help, I'm going to show you that there is a section to take you to education and training. Here, when you can click and check Solver Academy. These are, we have courses, advanced courses available if you want to learn more about our products. Okay. Now, the right section, the task pane. So let's quickly talk about task pane and move on to build our optimization model. This is called task pane. First tab is model tab. This shows you your model in outline form. Under optimization, you can see you have objective, variables, constraints, and now it's empty because we're going to define this optimization model from scratch together. Then we have the platform tab. Platform tab allows you to have access to different optimization simulation options. For example, how many optimizations to run. Then you have the engine tab. Here you can select a solver engine and set its options. When you install Analytic Solver, you will have access to different engines that are standard optimization engines that allow you to run different optimization model, solve different optimization model structures. For example, we have LP quadratic engine that helps you solve linear programming and quadratic models. You have a standard GRG nonlinear, allows you to solve nonlinear type models. We have evolutionary engine, and you can see I have some additional plugin engine to show you that we have 8 more optional larger scale solver engines. These are the world's best algorithms and softwares to handle the biggest optimization problems of each type. So to use those, you have to download them separately and access them. For example, Groby, Nitro, Express, OptQuest, and much more. There is an option to automatically select engine when you don't know what is the structure of your optimization model. For now, let's keep the GRG, and I want to show you what would happen with other tools that are available with Analytic Solver when it comes to help. And there is a operating mode that we will talk more about. There's a guided mode, auto help mode, and expert mode, and I will show you how that can help you. Output gives you a log of solution messages, and with workflow during our data mining webinar, we will talk about how to build a multi-step data mining workflow. So back to model tab. Let's practice and build our optimization problem. Just before that, let me open my Office 365 to show you. So I just opened my Office 365 and went to Excel Online. I want to just open a blank workbook and show you how you can open and access Analytic Solver Cloud version. So if you have installed Analytic Solver, it will show up on the ribbon. So this is Excel Online, all-in-one version of Excel. You can see this is my browser. And I've already inserted Analytic Solver. But if you haven't, just go to Insert, go to Office Add-ins, search for Analytic Solver, and then add Analytic Solver. And if I click on Analytic Solver, you can see the ribbon. Let me increase the size. You can appreciate that the ribbon is exactly or pretty much very similar to what you saw in Excel version, desktop version. So you can save your models on the cloud and access them, run them, and solve them using Analytic Solver Cloud. Okay, so let's go back to Excel. And if I open a model, it will ask me if I want to check out my license. I use the cloud version. And for now, I'm just going to close that and go back to this one. So this is a simple, easy to follow transportation problem. To show you the network, this is about a company with 2 factories that want to minimize cost of shipping to 5 different customers. Very simple. Each factory has its limited supply and each customer has a certain demand. Our goal is to find the best shipment plan to meet the demand in the most cost-effective way given the supply available. Now, what do we need to do to use optimization and get the best results? Here are the steps we have to take. We have to build a model that goes from the business situation in the quantitative terms to a model that we can solve using Analytic Solver. To achieve this, we have to determine our decision variables, objective, and constraints. So you can determine your decision variables by asking with this basic question, basically, what factors are under our control? In this business transportation problem, decisions about how much to ship along each route are under our control. So those are each possible route and the amount of product to ship on them is your decision variable. Then you have to determine your objective. You can ask, what measure are we trying to optimize? Our goal in this problem is to minimize the shipping costs from factories to customers. And for the constraints, you have to find out what are the restrictions, what limits your choice of decision variables. So here we have the supply, limited supply that is available in each factory. Also, you have to meet demand. So these are your decision variables. Also, you want to make sure you have to tell solver, hey, in each route, I have to take positive, you have to give me positive values for demand, for the values to be shipped, or 0 or positive, okay? Okay, so let's go back and apply this to our optimization problem. Here you can see that in this Excel workbook, we have the cost per unit of shipping from factories to customers. We have factory capacity 60,000 units, and then we have the demand on the customers, so 5 different customers. I've organized the data. Now we have to define the formulas and also define decision variables, constraints, and objective, and solve the optimization. So what is under our control are decisions about how much to ship along each route. So let's define all possible routes. From factory 1, we can ship to all customers, all 5 customers, and from factory 2, we can ship to all 5 customers. So these are all possible routes. So I have to reserve all these cells as to represent quantity shipped from factories to customers. And this is how you define decision variables. You want to reserve these cells and tell Analytic Solver these are all the possible routes or all my decision variables. So select those cells. You can do it one by one, or the easiest way is to define decision variables as blocks. So select the whole block, go to ribbon, optimization model, decision, and then normal. As soon as I click on normal, under optimization in the task pane, you can verify that I have done this correctly. C16 through G17 is defined as our block of decision variables. Next, what measure are we trying to optimize? We want to provide the service with minimum cost and ensure that each customer demand is completely satisfied. So ensuring that everything is happening with minimum cost is our goal, right? So minimization of total cost of shipment. So let's define this measure. So along all the routes, we have to calculate all the possible costs and then define the objective function. So to do that, select an empty cell. This is our objective. This is the cell I want to use. This is an empty cell. And we can define our objective function or the measure that we want to optimize using a function. Okay, so I can just type in a sum product to calculate the cost of shipping from factories to customers. So the cost, and then select the first array, which is the cost coefficients from C11 to G12, comma, all the decision variables to calculate the total cost of shipping along all possible routes. And then hit enter. So let me hover over it. It's a sum product of shipping cost and product shipped. So far, I just defined the measure that I want to optimize. Now I have to tell Analytic solver, here is my objective cell and what to do with it. So select this cell, go to objective on the ribbon. We need to minimize. This is the normal optimization problem. It's like a deterministic, because the expected chance is when you have uncertainty in your optimization model, basically. So objective, select the cell, go to ribbon, minimize, normal. Now look to the right. Under objective, we have G21 to be minimized. Now, our constraints. What restrictions limit our choice of decision variables? What restrictions limit this shipping plan? Factory capacities, right? So let's tell Analytic solver that the total that is shipped out of factory 1 should be less than its or equal to its capacity. Similarly, we have to tell Analytic solver that, hey, the total that's shipped out of factory 2 should not go over what is available at that factory. Okay, so to do that, it's very straightforward. We just need to calculate the totals, right? So let's define just some functions. So I select cell H16 equals sum, and then start from C16 to G16. Close the parentheses and enter. And I'm going to drag and drop it. Let's make sure. So I have calculated the totals. And then now let's define the constraint. Select this block. You can do both of them at the same time, or you can do it one by one. Go to constraints on the ribbon, normal constraints. You can go less than or equal to, right? Because I want to make sure H16 and H17 are less than or equal to, and then I'm going to click on this button and point to factory capacity. So let's do that together. Select these two cells. And let's talk more about this. So this is the add constraint dialog. You have the left-hand side, then you have the right-hand side. And in the left-hand side, if you have like two cells, you want to make sure you have two on the right. And it's really good. It will actually complain if that's not accurate. This is easy, like it's a small model, but if you have a larger model, you have to kind of watch for that. And then these are the different signs that you can have. So if this one, we want to make sure factory capacity constraint is satisfied. Then you can give a comment and click OK. Now look to the right to make sure we have defined this constraint correctly. Also, there is an option to correct your optimization model components down in the model tab, so you can see the components and then you can edit them down here. That was our first constraint. Now let's make sure our demand is satisfied. So to do that, you have to calculate the total that is shipped to each customer from factory 1 and factory 2. So I'm going to do, you can just add them, right? Equal this C16 plus C17, right? And then we can drag and drop it. Let's check, make sure this is G16 to G17. And to make this look better, I'm going to insert 0 for all decision variables, okay? So now I have these, and I want to make sure the totals that is shipped to each customer is satisfying the customer demand. So let's go to constraint again, constraint, normal constraint. This time I'm going to use greater than or equal. C18 through G18 should be greater than or equal to C19 through G19. Okay. And it's not a should, it's actually a must. We want to ensure that the results that you're getting and customer demands are satisfied. So click OK. By doing this, I have told Analytic Solver that I want to make sure the customer demands are satisfied in my solution. Now, one more thing we have to do, we have to tell Analytic Solver, this is a minimization problem, but it's a good practice to also define non-negativity on decision variables. And you can do this multiple ways. One of the easiest way to set bound for a decision variable is just define as a constraint. So select your decision variables, go to constraint, variable type bound, and let's set a bound of greater than or equal to 0. Just the same way when we defined our constraints, and click OK. This is one way of doing this. Another way is to go under Engine tab, and there is an option to set Assume non-negative. So if you check this option from false to true, it actually tells the solver that our decision variables need to take positive values. So now we are ready to solve this optimization model. We don't know anything about the structure of this optimization problem, but if you pay attention, all the functions are linear functions of decision variables. So we expect to get a linear model. And also you have to kind of decide which engine we want to use. Not knowing any of that and not even paying attention to the structure, I remember I showed you there's a guided mode. So let's click on optimize. And the guided mode is by default active. So when I click on this light bulb on the ribbon to solve this optimization problem, so I'm just going to click on the light bulb. Let's do that. You will see the guided mode show up. So this is the first dialog. This is a step-by-step help offering you information and assistance to prevent common errors and help you walk through the steps of solving an optimization problem. So let's click on continue. Two things happened here. First, Analytic Solver automatically analyzes all the formulas, and it's letting us know that this model is linear programming convex. Great, so now we have more information. We define an optimization model, and if we didn't know, now we know for sure it is linear programming convex. You see a large list of solver engine, and this is because I have all the engines installed. So it actually looks through engines that are available in your Analytic Solver version and tells you what is the best choice to choose. So you can see that my choice, which was GRG, and I purposely did that to show you that this tool is how this tool can help you. This nonlinear engine is not proper for solving a linear programming convex model, and any of these other engines can solve it. The first three are the ones that are additional plugin engines. So when you install Analytic Solver, you don't see them. And what you would see is a standard LP quadratic, which is a great engine for solving linear programming convex models. So let's select that and click on next step. Now we get a message that Solver found the optimal solution. Here is the solution. We achieved what we wanted here, which was to determine how best to ship products between the factories and customers to minimize our shipping cost, which is about $192,750. I showed you with the engine. If you are not sure which engine to use, you can always use automatically select engine or use the guided mode to help you verify if you have done anything, if you need to change anything. If you go to help, let me show you again that under help operating mode, you can change this guided mode. So this is the guided mode. You can use auto help mode if you don't want to get those dialects after you've run your model and now it's just rerunning and you know everything. Then you can just switch to auto help mode, which will only bring dialects when there's a problem. Expert mode totally eliminates help. Okay, so now we have reviewed how to model and solve a business problem in using Analytic Solver in Excel. Now it is time to move along into deployment using Create App. Let's click on Create App. As you can see here, there are options allowing our optimization model to be deployed to the cloud with cloud service. Also, the other options allowing it to be packed for Tableau and Power BI. And I can actually check and show you. These are Tableau, but Power BI options, Tableau options, Solver SDK, having your application on your PC or your server, and then Quick Test. That allows you to have a web page. You might be hearing some unfamiliar terms, but help is on the way and we will go over some more details about this. So first, I want to show you two approaches to deploy our optimization model. First, we export the Excel model itself as is, as an Excel file. Second, we translate all the Excel formulas and data in the model to equivalent expressions and data in a RASON modeling language. So let's do that together. Let's erase all the drawings. Let's go to Cloud Service. We want to deploy our Excel workbook to the cloud, to the RASON server, to use it as a cloud service, just as it's just as an Excel model without translating it to RASON modeling language. So let's click on Excel model. It's a very simple option. Here you can give a name to your model. So let's call it Transportation Optimization Excel. So TO Excel, okay? You can also have your model on OneDrive and then post it to the server. Let's click on Save. By doing this, it saves our model to Azure Cloud. It saves a copy of the workbook in my account on the public RASON Cloud service under my account. You can see rason.com automatically opens. This is rason.com. This is your REST API, and we'll talk more about this. On the left side, you can see all the models that I have on the server, on the RASON REST server. So this is an API allowing you to manage all the models that you have posted and that I can use as cloud services, whether they are RASON models or they're Excel models. So you can see our TO Excel workbook is here. And it is just in its Excel format. There's this editor showing you the model structure. And it has a version. Here you have this model information right here. We'll talk more about rason.com, but also you have different endpoints here to solve this Excel model on the RASON server. So let's click on solve or optimize. Here you get a report of what's happening. On the left side, under the model, you can see the results are available. So you can just click on results to get the results from the server, from the cloud server. For now, let's keep it here and then we talk more about this, okay? Let's go back to Excel. Just wanted you to see how you can use your Excel model as a cloud service with a click. With just one click, click on Create App, and then give it a name, post it to Azure Cloud. And then use your Excel model as a RESTful service. So if you have a large optimization model with hundreds of thousands of decision variables, you can just easily, like this, deploy your model to the RASON server and maintain it in Excel. Now, let's use the Create App further. So let's click on Create App. This time, let's use Cloud Service RASON model. Let's give it a name, TO RASON, and click on Save. Immediately, browser opens, and then here, okay. This is the model. It is in JSON language in RASON.com. This is the automatic translation of your Excel model into RASON modeling language. You can see that the model is automatically translated. You don't need to know the programming. Here's the model name. These are the variables. These are data, objectives. Now let's look to the left. It was TO RASON. This is our model. You can see I have my TO Excel and TO RASON. This is the version. If I open TO Excel, you can see I have different versions of that one, and I got the results. This is the TO RASON, transportation RASON model. It's available now. Let me show you. We can quickly click on, it's already posted to our RASON server, so you can just go. You can also do the quick runs, but I just want to show you. You click on Optimize. It will solve the model. Results are available. Click on that to get the results from RASON server. Okay. Now it's a good time to review some basic information for those of us who are not very familiar with these terms, such as RESTful service, REST API, cloud service, RASON server, or JSON. So let's go back to the PowerPoint slides. I want to make sure you get a little bit more than just the steps to do this. Imagine if you want to build a web application and have something with its own user interface. So you want to have a model that can be deployed for a large number of people, or you want to set it up so it can be run or rerun on demand. Most applications follow this structure. So your application is the front end, the client. On the back end, it needs to talk with the server, post the model, solve it, get the result, or update the model. When you send a request to a server, you want to get the data in a structured format. Your data can be returned in JSON or OData, for example. API stands for Application Programming Interface. It's the way to connect you and the server. REST API is an API that follows the rules of REST specification. REST is how communication over the web is happening, is the underlying architecture of the web. So as a RESTful service, you can use various HTTP verbs such as post, put, get, and delete operations. For example, when you fill out a form on like solver.com to create an account, you're actually you're posting your information to the server, create a new account, and then it's very similar with RASON.com. RASON is a REST API. It's a service that's running on Azure, and it's a cloud service, okay? So you can build and test your models in Excel using Analytic Solver, and then with that Create App button, you can deploy your models to the RASON server. Also, let's go back. So this is the RASON.com. RASON.com is a REST API, so it's your interface to communicate with our RASON REST server. This is just one way showing you how you can connect to the server. Of course, there are other ways. We have implemented to make it very easy for you to deploy your models and manage them, run them, get the results. And these are standard REST API calls. I told you you can use post, put, get. And let's walk through this with the quick runs. You can use the post, quickly run the models. And then I will hover over this here. You can create a blank workbook document, post a model, put the model. So put is when you just want to update the model that's already on the server. Then you have different model execution options for solving. So post solve, for example, if this is optimization, you optimize, post optimize. You can stop it, and then you can get the status and the results. There are more examples available if you want to learn more about RASON language on the optimization, simulation, data mining. There is much more available here when it comes to decision flows, decision tables. You can have multi-stage decision flows here in optimization and simulation that can feed it into each other, can feed from the optimization results to a simulation model, and much more. So back to our models that we have. So the first one, we posted our Excel workbook, if you recall, RASON REST server. We used, so it was already posted, and then I clicked on optimize to get the results. Similarly, so I am managing the model, getting the results here on RASON API. Similarly, we had the TO RASON. We posted to the server from Excel with just a few clicks, and we can manage it here, solving it and getting the results. Let's go back and explore these options further. This might be a little confusing, I know, but I promise you, you will master this readily. Frontline has made this very simple. It's just maybe unfamiliar, but if you just explore this little further, you would just master this very quick. And we have a very nice help document and a support team that can support you during this process. Okay, back to Excel. So we have a model, we built it in Excel, and we're talking about different deployment options. So I showed you two ways to deploy this Excel model. One is to use it Excel as is. We posted the Excel model itself. The second one was to translate it to RASON modeling language. And both of them, they were completed for you automatically. Now let's show you other things that you have with the Create app. One is that there is a deployment wizard that helps you choose your deployment option. So let's click on that. I want to show you that you can click on next. It walks you through steps of what you need to do, what are the options available, and what you want to use. And then another one is the Manage Models tool. It actually connects to RASON, and it's similar to what you just saw in RASON on the models. These are all the models I have under my account on RASON server. You can see that I have the TO Excel, I have the TO RASON that we posted. This is how interconnected Analytic Solver and RASON are. On the top, you can see we have all the RASON models. You can choose to just see your Excel models. These are all the Excel models I have on the server. You can check all the runs, for example. Okay, you can get more information. Okay, let's copy this name. I want to show you something more. Okay, so these are how you can manage your models even from Excel. You don't need to go to RASON. Let's go back to Create App and look at other options. So previously we used Create App Cloud Service and create a name model that lives on the public RASON Cloud Service. And these models on a RASON server can be used by any other application such as Power BI, Power Apps, You have to power stack products from Microsoft or any other application, okay? So let me show you one example how to use those models with Power BI. And it actually it is implemented for you here with Power BI. So let's click on Power BI, and you can do this two ways. Let's use Create App Power BI Manage Model. First, you will be prompted for the name of the model that you have previously posted on the RASON Cloud service, okay? And I want to invoke this model, TOXL. Okay, so the model is on RASON server, and I want to use Power BI, create a custom visual from that model on RASON server. So it's just like connects to the cloud, gets the results and display the visual for us. Okay, so let's click on save. Model is sitting on the server, and we're just getting the visuals and graphics on Power BI. Okay, so click on save. Here you just give it a name to have this Power BI visual. Let's call it TO Excel. Save. Immediately, these two command prompts appear. Here is creating the custom visual for us. Takes a few seconds. Meanwhile, I can open the Power BI desktop for you and create a blank page. You can see it's still working on it. Once it finishes, both dialogues will disappear. So with Create App, Power BI, Manage Model, after giving the name, a model that you have previously posted to the server, it calls the model from Power BI Custom Visual. So the model itself is not in the Power BI Custom Visual, it's just sitting on the server. So now it's finished. You can see the dialogues disappear. Follow me here to see how you can import a custom visual. Under visualization on the right, there are these three dots. Click on that, and you can see there is option for import a visual from a file. I can see the TOXL is available. Click open. Now click OK. And I was just running some tests. You can see the frontline system icon appears here. Now I'm going to click on that and show you the model. I don't think you can see this. Okay, let's redo this. So again, I'm going to click on the TOXL. You can see these gears show up. It's actually running the model on the server and updating the results for us, okay? It's a larger version here. There we go. And visualizes graphically, shows you the variable values and the constraints and the value of objective function. If you recall, it was 192,750. Okay, so now you could also use the other option. Let's go back to Excel. You can go to Create App, Power BI, and use Embed Model. And this does exactly the same thing. It would embed the whole optimization model in the custom visual, create and translate everything to RASON. For the sake of time, actually, I'm going to pause on this one, talk more actually about creating a web page, and then if you have extra time, we come back and perform that, okay? So let's go click on Create App. I'm going to show you another thing that you can do, another option that you have. In this one, I want to show you how you can create your own website and embed the optimization model that you created in Excel in JSON and run it on a RASON server, only with a few mouse clicks. So click on Quick Test. You can see there is an option here, Web Page. Quick Test, Web Page. Immediately, a browser opens. It's just okay. A browser opens, displaying the newly created web application from our transportation optimization model. As I clicked on Web Page button, the model on the spreadsheet would automatically translate it into RASON model. Then we received this HTML page. So on the top, you can see the model components. Here is the server where your model is sitting. This is your authorization token. If you have data file or RASON model, you can update them here. This is where you can post your data file. And this is the model in RASON modeling language in JSON. And then you have different endpoints that are created for you. And this is, if you notice here, this is the HTML web page. So let's first quickly solve this model using the solve endpoint. We've implemented this solve endpoint just like what you saw on rason.com. So let's click on solve. It posts the model to server, gets an update, says it's still incomplete, then it solves it and gets the final variable values and the objective, right? 192,750, and brings the results. This is the model structure. You can right click and click on view page source. You can see this is the HTML page that uses simple JavaScript. So this is the simple JavaScript part. Then this is the model part. All the components are optimization model from here to here. Okay, this part is a model part. Okay, and then after that, these are the other things that are implemented in the template to show you how you can use these Ajax calls to solve the optimization. This is the quick solve function. This is the quick simulate if you are posting a simulation as a web page, and much more options. So this template is shipped with our software. It sits in your example folder, and you can double click, open it, and modify it for your desired web page shape. And this was just another example that's implemented, another way that was implemented to communicate, to show you how you can communicate with RASON REST API, how you can create your own website, embed your model, solve it on RASON server, and get the results just with a few points and clicks. There's much more you can do with the create app option. At this time, I'm going to just take a quickly look at questions. Thank you, Dan, for answering all your questions. And I'm going to share some of them with you. Before that, let's have a summary, and then we can explore more options and maybe a few more examples as time allows. Today, we were able to briefly cover optimization and then deployment using Analytic Solver plus RASON. This was just an introductory webinar to give you a sense of what you can accomplish. Analytic Solver plus RASON is a complete decision management suite that supports the full range of business rules, forecasting, machine learning, optimization, simulation, from small to large, and also multi-stage analytic workflows. RASON is a platform for analytic power decision management. It works really easily with Microsoft Tech Stack. I'd show you how easily it works with Power BI, and in upcoming webinars, we'll show you how it easily works with Power Apps, Power Automate, and Dynamics 365. Especially with it allows you to deploy and manage your data really easily with Office 365, Dynamics 365, Common Data Services, OneDrive, and CData's Cloud Hub. It allows you to work with OData standards, get your outcomes in OData. So RASON enables easy even easier use of analytic model results. So when you have a trial version of Analytic Solver, you will also have access to a trial version of RASON. We invite you to keep exploring these new avenues to generate more value for yourself and your organization. There is much more you can accomplish with RASON. You can create data connections, you can manage your models, and you can create multi-stage flows of rules, predictive and prescriptive steps. We have some other fantastic scheduling tools available to you. You have automatic scheduling available in RASON, so you can set a time and you can set some rules that when you want to rerun your models, how new you want the results to be, and all of these are available with a few with very easily implemented options. Okay, now it's really good time to. This is actually showing you graphics of how you can create multi-stage decision flows. I didn't cover this was beyond our introductory webinar, but you can easily create multi-stage decision flows and also implement automatic scheduling with RASON. You can create your flows in graphic form and also with a little bit more programming. Okay, so let's go to your questions. Okay, so thank you, Dan, for answering all the questions. So these are some next steps for you. You can create your free trial account with analyticsolver.com and then rason.com. Explore. Let me show you some more information on rason.com. So let's go to rason.com. So if you can see, RASON stands for RESTful Analytic Solver Object Notation. Now you know it is a modeling language and you understand what it means when we say it's a REST API. It's your interface with the rules of REST that allows you to create, test, and deploy your decision services powered by your analytic models in web and mobile applications. Okay, so then you can go to editor page. This is what was the page. This is the page that you would automatically get here when you start from Excel. But now that you're familiar with that, you can come to rason.com, come to editor page, and click on different examples. You can work with create app from rason.com to create applications in Power BI, Tableau, and web page. You can click on help to access RASON user guide. So click on RASON download user guide, has a step-by-step information showing you what you can do with RASON and programming RASON language. You can download RASON reference guide. You can go to your account, create data connections. Just click on create a new data connection. You can create your source of data connection, what kind of connection you want. For example, you can easily create a Microsoft OneDrive connection. Give it a name, what's the path, what files you have. If you remember, I told you that this is also available. So feel free, come to rason.com, create your own account, explore this tool, access the example models available under editor, RASON examples. Okay, all the examples are available. For example, go to optimization. There are examples available for linear, nonlinear optimization. Feel free to look at decision tables and also decision flows. And these are the data files that you might need to run some of these examples. Okay, thank you very much. Feel free to reach out. If you have any questions, you can email me at simo@solver.com. I forgot to introduce myself. My name is Simo Maliki. I have my PhD in Industrial and Systems Engineering, and I have joined Frontline Systems in 2013. Thank you very much for your attention. I trust the webinar was helpful. Feel free to reach out with your questions and download trial versions. Explore this tool. You will get very familiar with this tool. This is implemented and this is made, that has been made available for anybody that is a programming and anybody that who is not a programming. This is very straightforward. I promise you, with some exploration and running some examples, you will master this really quick. Okay. And if you have any questions during this process, feel free to reach out. You're welcome to join us next week. This is our main phone number. Today, Dan wants us to use a better one. So it's 831 0300 775 831 0300. Okay, let's see. Thank you very much again. We appreciate your time. So Dan has posted some information for you on the chat box. Dan, thank you very much for joining us today and providing us with your feedback and answering all the questions. So I'm going to read some of this information in the chat box. Also, feel free to download the product catalog that was created by Dan. It's a wonderful summary that was also emailed to you about what you can accomplish with Analytic Solver plus the power of RASON, okay? So make sure to read the information Dan has posted for you in the chat box. Remember that your personal license for Analytic Solver entitles you, allows you to use both the desktop version and the cloud-based version of Analytic Solver. And Excel workbook models are interchangeable between the two versions. You can easily save your models on the cloud and run it and on the Excel, desktop Excel, or the cloud-based version of Analytic Solver. Okay, if you have any further questions, please feel free to type them in the chat box. Thank you very much for joining us. Have a wonderful rest of the day.